All right, let's go ahead and take care of this practice test. I'm going to crank through this pretty quickly, but listen to some of the hints and tips. And as always, head back into those lessons in the notes or homework to get more practice or things like that. All right, lesson one is I'm going to be solving equations. We're going to separate our workspace like we always do. We're doing opposite order of operations, so SAD-MERG to solve for variables. So I'm going to add 11 to both sides. By doing that, we end up with different signs subtract. 11, 10, 9, 8, 7, 6 equals 3x. And then our next step is to go ahead and isolate the variable by dividing both sides by 3. And we end up with x equals 2. Okay. On the right side for this problem, it's going to be a similar equation. Okay, let's look at these hints. Caden bought a candy bar for $2.58 and 6 bottles of pop. We just don't know how much the bottles of pop are. He spent a total of that much. So I know that my equation is going to equal $10.26. Okay, because that's a pretty typical pattern there. And then we have this expression on the left side of 258 plus 6 bottles of pop. I could do P for that. Okay, for price of pop or whatever. Let's go ahead and separate your workspace and solve for P to find out what the price of that pop is. Okay, I'm going to go ahead and subtract 258 on both sides. And then let's see what we're left with. 6P equals 1026 minus 258. Let's go ahead and bring up Desmos here. And we'll do the big version here. All right, so 1026 minus 2.58, and you can see we have 7.68. And then we're going to go ahead and divide both sides by 6 to isolate that variable. And we end up with P equals, going to hit return and do answer divided by 6. And we get, this is money, so $1.28. Okay, we do have to answer the question, take care of this sentence. So determine the cost of each bottle of pop. Each bottle of pop is or was $1.28. Okay, so there we go. All right, let's head to 3 and 4. 3 and 4 look like we're adding distributing now. So we always want to show our distributing arcs. Separate our workspace here. So 10 times x is 10x. And then 10 times a negative 10 is negative 100 equals negative 40. Let's go ahead and start moving some things around here. So we have add 100 to both sides. That gets rid of that. And we're then left with 10x equals 100 minus 40 is 60. Now we can go ahead and divide both sides by 10. And we end up with a final answer of x equals 60 divided by 10, which is 6. Okay, so there's that. We're going to, because we have a distributive situation here in lesson 2, obviously the word problem is going to be distributive as well because it's lesson 2. So it's a nice little tip or hint here. So Ayla is making 5 scarves. That's my multiplier. What does each scarf require? Let's see. Each scarf requires 3 yards of purple fabric. So I'm going to create my parenthesis. 3 yards of purple plus an X amount of blue. So that's what one scarf is 3 purple plus a certain amount of blue. We're going to multiply that out to 5 scarves, and the total is 30 yards in all. So it's going to equal 30. It's a pretty common pattern. Let's go ahead and do our distributing. And so we end up with, if we separate our workspace here, 15 plus 5x equals 30. And then we can go ahead and start moving things around. So let's subtract 15 on both sides. Remember, we're doing opposite order of operations, SAD-MERG. And we're left with 5x equals 30 minus 15 is 15. And then we can go ahead and we have an x times 5, so we'll divide both sides by 5. And we are left with x equals 3. Okay, we need to answer the question. How many yards of blue fabric are needed? 3 yards of blue fabric is needed. Okay. All right, let's go ahead and take a look at number 5. So this is lesson 3 stuff. Okay, and we have variables on both sides. So let's separate the workspace. So you can move around whatever you want. You just have to get the variables all on one side and the constants all on one side. So I typically take care of these constants first, add 5 to both sides, crosses that out, and we have negative 2a equals 8a, and then plus 20. Okay, now we're going to get that a over there, so I'm going to subtract 8a to both sides because I have a positive 8a, and then we'll be left with negative 10a equals 20. Okay, let's go ahead and isolate the variable. We have a times negative 10, so we're going to divide both sides by negative 10. And then we're left with a equals 20 divided by 10 is 2, but it's negative 2. Okay. All right, now let's go ahead, since we're dealing with variables on both sides, our word problem is going to be the same style. So that helps us out here. So we have Ben and Vern, and it says that how many months will Ben and Vern have the same number of comic books? So we're going to set Ben and Vern equal to each other. So we have Ben has 30 comics in his collection, and he buys 2 books each month. So we're joining more books, so that's going to be addition. And 5 books each month, I know each typically means multiplication, so that's going to be 5 books per month, so times M. So that's Ben's side. Okay, Vern's side is going to be 28 comic books and 6 new ones each month, so plus 6 per month. And we set them equal to each other because it says after how many months will they have the same number of comic books. So let's go ahead and separate our space here. You can start moving anything you want around. So you could move the 30 over there. You could move the 5M, whatever you want. I'm going to go ahead and just subtract 28 to both sides. That gets crossed off. And let's see what we have then. 30 minus 28 puts us at 2 plus 5m equals 6m. Okay, now I need to get the m's over there, so we're going to subtract 5m, subtract 5m. That makes that go away, and we're left with 2 equals 6 minus 5 is 1m, and we're actually done. 2 equals m. All right, let's answer the question. So after how many months will Ben and Vern have the same number of comic books? They will have the same number of comics after 2 months. Doesn't take very long. All right, let's go on to number 7. This is lesson 4, which is distributing and combining like terms. Okay, so with variables on both sides. So let's go ahead and do our distributing arcs here and get this distributed. I like to put a negative 1x when I don't see the coefficient. And then we have 4 times 2 is 8 plus 4x equals negative 2x. And then negative 2 times 2 is 4, but negative 4. So we're just writing minus 4. We always are going to highlight like terms. Remember, that only happens on the one side of the equal sign. You can't cross over like that. Okay, and then we can go ahead and combine those like terms. So 4 minus 1 is 3x plus 8 equals negative 2x minus 4. Now everything is simplified. We can start moving stuff around. So why don't I go ahead and do not plus 8, plus 4, plus 4. That makes that go away, and we're left with 3x, 8, 9, 10, 11, 12. So plus 12 equals negative 2x. We need to move that x over. So I have to do minus 3x minus 3x. Or we're not doing the dividing until the very end. That goes away, and we're left with 12 equals negative 5x. Okay. All right, now I have to isolate the variable. So we're going to divide by negative 5, divide by negative 5. That goes away, and we're left with x equals 12 divided by negative 5. So let's see what that looks like. 12 divided by negative 5 is just negative 2.4. So there we go. okay? Or you could write it as a mixed number or whatever, but there we go. All right, let's slide over here. We have some same thing, but decimal distributing and a distributing of a negative. So I always start with my arcs. I also have a negative. You could look at that as a -1 if you want, however you prefer, okay? And so we have 0.6. So 0.6 times 2 is 1.2. And then minus, I'm just going to, actually, we already know that that's 1.2 also, 1.2x. That was easy. And then we have 0.4. And then distributing the negative, we now have a -3x and a -10. Okay, let's go ahead and combine like terms. We have a constant here and a constant here that we need to combine. And so we end up with 1.2 minus 1.2x equals, and then we need to go ahead and combine that. So a -10 and a positive 0.4 would put us at 9.6, but we never really want to completely trust that. So 0.4 minus 10, let's see, yep, -9.6. Okay, always good to check with your calculator. All right, let's go ahead and move some things around. So we have a positive 1.2. I want to subtract 1.2 on both sides. To get rid of that, we want all the variables on one side. And we're left with -1.2x equals, and let's go ahead and add up the 9.6. It should be 10.8, but again, let's just make sure. So we have a -9.6 minus 1.2, and yep, -10.8. Okay, now we can isolate the variable. We have an x times -1.2, so let's go ahead and divide by -1.2. Cross that out, and we're left with x equals whatever that makes. So let's go ahead and hit answer divided by -1.2, and it actually just equals a whole number of 9. Okay, and there we go with number 8. All right, we're on to the second and last page. These are the ones that say one solution, no solution, or infinite. A note to remember is just help yourself by writing, okay, well, it could be like 4 equals 4, it could be 4 equals 5, or it could be x equals 4, something like that. So this is no solution, this is one solution, and this one is infinite. Okay, when you see the same thing on both sides. So it's just a trick to make it so you don't have to be thinking about it when you get there. So first thing we have to do is get these simplified so we can analyze them, and we're going to do that always by distributing first, okay, unless we don't have a variable. Let's go ahead and see what we get. So we have 4k minus 6 equals 4k minus 16, because 4 times 4, plus 10, okay? I see I have some like terms, so I'm going to combine these like terms, and let's see what we get. We have 4k minus 6 equals 4k, and -16 plus 10 is minus 6. So I can see already that both sides are the same. And if I look up here, when both sides are the same, that means that we have infinite solutions. Because any number you put in for k is going to make a true statement. So k can be anything. All right, let's go ahead and try that over here and see what we get. Separate our workspace. Obviously, we're going to start off by distributing again. This is a pattern that we do every time. And so we have 12 minus 30w equals 15 minus 10w minus 20w, because we did that distributing. Let's go ahead and combine like terms. We have a -10w and a -20w. And when we do that, we end up with 12 minus 30w equals 15 minus 30w. So these ones don't end up being the same thing, but if we continue this on, look what happens. The minus 30w's, the coefficients are the same. So if I do the same thing to both sides, those go away, and I'm left with 12 equals 15. Two numbers that do not equal each other, which means that we have no solution. Okay, So there's those two examples. All right, let's go ahead and get to our inequalities now. And this is your most familiar stuff. We have a one-step inequality, which means you do one move and it's pretty much done. So we're going to add 4 to both sides here. That goes away, and you are now left with x, and we have our symbol there, and 12, 13, 14, 15, 16. Okay, so there's our inequality. We need to graph it. So remember, we make a straight line, 3 tick marks, tick, 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 boom. And then we go ahead and write the target number, which is 16, one bigger, one smaller to make the number line. Now look at your inequality, okay? And I see the cement, okay, or the is equal to. So if there's cement on the bottom, then we fill in the circle. And then we always read from the variable this way. So x is greater than, so we're drawing to the right. If x was less than, we would go to the left. All right, let's go ahead and do this one step. Okay, maybe you can see what's going to happen here. So divide both sides by 3. That crosses out. And anytime when you multiply or divide by a negative, you must change the sign. So multiplying or dividing by negatives messes things up. 3, 6, 9, 12, 15. We have 5 here. Okay, so you got to be really careful. Make sure you remember to change the sign when you multiply or divide by a negative. Tick, 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 boom. Write your target number. And then look, is it closed or open circle? Well, it's not is equal to. There's no cement line underneath is our trick. So it's an open circle. Read from the variable x is less than. So the arrow goes to the left. So any x you put that is less than that will work and be true. All right, last 2 problems and we're all set. So solve the inequality and graph. The only difference with this is it's a 2-step inequality. So we're just doing 2 things. You've done way harder equation work before. Okay. All right. So opposite order of operations. So we're doing SADMERG. So subtract 3 on both sides first. That goes away, and we're left with -9. Notice we just subtracted 3. We didn't multiply or divide. So sign stays the same. 3x. And then we need to isolate the variable, divide both sides by 3, and we are left with a final answer of x is greater than or equal to 9 divided by 3 is 3, but it's negative, so -3. Okay, we're going to go ahead and graph this. There's our straight line with our arrows. 3 tick marks, tick, tick, tick. Write our target number, which is -3. 1 bigger, which would be -2. 1 smaller would be -4. Change colors, closed or open circle. I can see the cement down there on the bottom. So that's my reminder that it's closed. Okay, like a cemented in hole. Read from the variable, and we have x is greater than or equal to. And so that goes to the right. Okay. All right, we know that we have an inequality for this lesson, so we're going to be making that. We've talked about the patterns that exist. So ready? Mia needs at least 132. That's sort of my answer. You got to know what at least means. Okay, so do I want more than 132 or less than? I want at least 132. Am I okay with more? Yeah, so that means greater than. Am I good with 132? Yes, at least that. So there's my answer spot. So that's my first tip to you is figure that part out and write it down. Now we can figure out the expression on the left side. So she wants to buy some new Nike shoes. She's already saved 20. Okay, so that's happened. And she earns $8 per hour babysitting Spencer. I know per typically means multiply. And am I adding money or losing it? Well, I'm gaining more money. So we're adding $8 per hour. Okay, write and solve the inequality, done, then interpret the solution. So let's go ahead and solve this out and find out how many hours so that we have greater than or equal to $132. So we're going to do opposite order of operations, subtract 20 to both sides, and we have our 8h is greater than or equal to 132 minus 20, which is 112. But again, if it's a test, I'm double checking all my thinking on a calculator unless it's crazy easy. So 112. Now we need to isolate the variable. We have h times 8, so we're going to divide 8 on both sides. Cross that out, and I didn't multiply or divide by negative, so everything's staying the same here. and we have 112, so answer divided by 8, and that's 14 hours. So let's go ahead and interpret the solution, which means write a sentence. So how many hours will she need to babysit? Okay. She will need to babysit. And then we use the phrase up above right there. Okay. At least, then we can continue, 14 hours. Okay, if she does more than 14 hours, she'll definitely make it, but she needs at least 14 hours. All right, that's your entire test. If you have any questions, let me know.